A very good morning to one and all present here. I am Jaganathan S, pursuing my bachelor's degree in Quantum of Technology. I came forward here to explain on the topic of grinding wheel, the types, their structures, and their nomenclature. Let me move into it. First of all, let me clear about the grinding process. We all know that grinding is one of the secondary manufacturing process, and it is also a versatile process too, because um, some of the job is hard to machine in machining process such as a milling and drilling process, but in grinding process which cannot be done through that milling and the drilling process, it can be done here because it has a high abrasive materials coated into it, which will fetch a good smoothing surface on the workpiece or a job. So the most important parameter of the grinding process is a grinding wheel. So it only gives the surface finishes of the job or a workpiece. So let me look into it. A grinding wheel is a wheel used for grinding, as you all know that. But in grinding wheels, they are composed of abrasive compounds and are used for various grinding. Grinding is nothing but it is also called as abrasive cutting because the abrasive particles were impinged on the grinding wheel, and it is also called as abrasive machine operation. And such wheels are used in the grinding machines, and grinding process are mainly used in machining materials which are too hard for other machining, as I mentioned earlier, on process such as tool, die steels, and hardened steel materials. Our There is a one fact like our ancestors they used stones for machining the weapons and the instruments they are using. But nowadays we are making like a composite material, a composite abrasive material, which is known as a grinding wheel for better surface finish, and for sharp finish surface also we can also tell like that. So it also gives close dimensional accuracy of the order of 0.3 to 0.5 mm. See how close it was, 0.2 to 0.0 mm, it can give dimensional accuracy. And also it results in a high degree of a surface smoothness. That means the integrity of the surface will be very, very, very smooth on using grinding wheel. Next we moving into the structure of a grinding wheel. So structure of a grinding wheel means the when uh, when the structure of the grinding wheels will be seen into means it will seen means when we look the grinding wheel in a microscope, it will the right side of image you can see that there is a many parameters in that grinding structure, like bond material, porous and abrasive grades, and etc. Let me brief it in the further slides. First, this is the main thing. There's three important parameters used in the structures. In grinding wheels, normally the grinding abrasive particles will be impinged on the grinding wheel. That means they will be making as a one thing, and they will be surrounding. They will be attached with the grinding wheels. So it is also called as a grids like structure because the abrasive grains that is impinged on the grinding wheels, it is known as a grids, which perform a cutting or a material removal process. They are only the thing which remove the material of the job. You can see here this. See this like structure only they will use for this are like the abrasive grains particle that will remove the particles of the workpiece. And the structure of the grinding will represents the grain spacing. It can be open or dense. So the distance between the grain particles will be called as a grain spacing. Here the in next slide I will detail explain what is the open structure and dense structure grinding, open section and dense structure of a grinding wheel. So here you can look into it is like a open structure grinding wheel. On next slide you will be get clear into it. And this also helps in avoiding loading of the grinding wheel. Basically we we place a grinding wheel on mounting surface, and we move the grinding wheel opposite to the surface, opposite to the workpiece. Then only the material removal process will be happen. That means the chip removal process, and therefore only the machine surface will be got a super finish. So there are two types of structures in there are structures in a grinding wheel, that is the open structure and a closed structure. In normal sense, open structure are used for a high stock removal and consequently for a rough finish, and dense structure are used for precise precision form and profile grinding. Let me see in the next slide. See, this is the basic difference between the dense structure and the open structure of a grinding wheel. In dense structure, the content of the grains are more, that means increases. See in here, the you can see the grains are tightly packed, means you can see here the grains are well tightly packed, that means volume of the force gets decreases. So the distance between the grains in the grinding wheel is short. So you can see here, the you can compare it with the open structure here on the left side and the dense structure on the right side, and middle it is be designated as a medium structure. On the disc texture you can see that the distance between the grains is very 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 small, so they are so tightly packed. So as a result, the contact point between the grain and the workpiece is more, because when this dense structure is mounted on a grinding wheel and you can perform the job on a you can perform a job, means the removal rate will be very 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 precise, means it will let me give an example. In a gillette gut, in a gillette guard means when we use for shaving, if we put two or three or more blades, means it will clean the shave in a clean the hair most accurate, and will be look so smooth. But if you use one blade, it will look like some hair will be impinged on the face. So in the same sense, a open structure will also give a surface finish, but also the like the two much not as like as dense structure. So the main difference between the dense structure and open structure is the surface integrity was high in dense structure as compared to the open structure. There are also another disadvantage in open structure. The easily the grain will adhere to crack in the sense when we rotating the grinding wheel opposite to the workshop, the grains tend to crack easily in the open structure as compared to dense structure. And the slag removing from the workpiece will also adhere easily in the open structure. You can see here there are many gaps in the open structure compared with the dense structure. So if the gaps are filled with that slag or that chip material, it is highly hard to remove, it is highly difficult to remove that slag out from that. It is going to it will be another going to perform an operation called truing and dressing process to remove that slag, and we again need to perform that grinding will. It means the two life will get severely affected, severely damaged, and we can and it will not give the expected outcome as we expected outcome as we expect. So but in the dense structure it is not like the case, because it is all like morely packed, so it will not give that much effect, that much crack, and or also the slag won't be able to adhere into it, because dense structure is closely packed and the surface is also very very high. For speed process, I don't need accuracy, but I need to speed, means you can go for open structure. I need accuracy, means you can go for dense structure. So this is the major thing between the open structure and the dense structure of a grinding wheel. Next, moving into types. Basically, the grinding wheel are classified in three major dimensions, like the diameter of the wheel, next the diameter of the spindle hole, that means the hole in the center of the grinding wheel. Next, face width of the grinding wheel. These are the three important parameters of dimensions in the grinding wheel. On onto that, the types of grinding wheel has been designated. So the I mentioned here type 1, type 2. In further slides it is designated type 6. So why this I mentioned the type 1, type 2 means, in shop if you go and ask for type 2 abrasive material, it is known as, it is normally called as cylindrical and building. So it is like a name for that, another name for that grinding wheel. So let me move to the straight wheel. Straight wheel is nothing but it is the basic grinding wheel used in many industries. It is generally used for cylindrical centralized and surface grinding operations, and it is also in this form of very greatly in size, because according to the job we can we can take the straight wheel grinding process, and the diameter and the width of the face also one of the consideration. Naturally, depending upon the class of the work for which is used, the size and power of the grinding machine. So we can also vary the size and the power of the grinding machine on performing the straight wheel operation. This is one of the advantage of the straight wheel. And next we moving to cylindrical and the wheel ring. We can see here the face width of the cylindrical is very high. It will give it will that means the very large amount of surface we can be grind using the cylindrical or wheel grind. Here mentioned as they can be where very large up to 12 inch in width, and cylindrical wheel provide a large and wide surface with no center mounting support, and they are also used in vertical or horizontal spindle grinders. There are two types of grinding machine in the grinding machine, namely vertical and horizontal. In both ways, the cylindrical or wheel ring cylindrical or wheel ring grinding material is used, and it is used for producing flat surfaces and the grinding being done with the end face of the wheel. This is the properties of the cylindrical and the wheel ring. Next we moving into straight cup. Straight cups, you can see here in straight wheel there is not a stepped like structure. Here the inside structure was totally removed. That means it is like hollow and outer diameter. It means the very. It means there is a thickness is very small in this straight cup grinding wheel. So it is one of the most familiar application of grinding wheels to polish stone and or concrete. The major application of the straight cup grinding wheel is a polished stone or a concrete. But with small enough grid, cup wheels can take on delicate jobs like paint and adhesive material. One of the important perspective, important one of the important thing in the straight cup is it can the wheels can delicately jobs like paint and adhesive removal, and the cup wheels are often used for resharpening and finishing for some application depending on the abrasive size. Next we moving into diamond wheels. Generally, the abrasives are classified into two types, like the natural abrasives and the artificial abrasives. Natural abrasives is nothing but like stone, sand. Using this, the grinding wheel can be made. Artificial abrasives like diamond, aluminum, aluminum oxide, next carbon, carbon boron nitrate. These are the some artificial abrasives which comes into play. Normally we use artificial abrasives because they have more hardness comparatively natural abrasives. So one of the artificial abrasives is known as a diamond wheels. This wheel is one of the most what to say, if you have a job, with the highest hardness, means take here I mentioned like carbide. Carbide is a job you have, you need to machine that carbide job, means you need to you need to have higher hardness than this job. That means the diamond is a suitable material. So diamond wheels are used for high precision and high hardened job machining process, and they are used for grinding extremely hard metals such as carbide cutting tips and the gemstones or a concrete. So these are the major parameter of the diamond wheels. Next, we moving into tappet wheels. So you can see here the tappet structure of the grinding wheels. It will it This arrangement is stronger than the straight wheels and can accept high lateral loads. High lateral loads in the sense, if you mount the tappet wheel on a mounting job and performing a job against performing a process against the job, the lateral loads means the perpendicular loads will be more on the grinding wheel. So on resisting that load, it need to perform that job. So high load bearing capacity is more in tapered wheels. Straight wheels also comparatively higher than both wheels. Both tapered and straight wheels have good load bearing capacity. And tapered wheel straight wheel is primarily used for grinding thread and gear teeth. This is major application of the tapered wheel gear teeth. You can see that in gear teeth the teeth looks like in a taper like structure. So for that machining process, this tapered wheel is used. It is one of the major application. Next, saucer wheel type, a special grinding profile that is used to grind milling cutters under twists. You can see by on reaching a particular time, the drilling cutting tool and the milling cutting tool will blend at some time. That means the two life ends, and it will not too sharp. It will blend. It will blend. So on to machine and to make sharp, the saucer type of wheel is used, on again to perform that action. So saucer type of wheel is one of the major application in the tool sharpening process. It is also most common in non-machining areas as saw fillers in saucer wheels in the maintenance of the saw blades. You can see that saw blades. It is also the saucer wheel also used to machine that saw blades process. So these are all the I mentioned like type 1, type 2, type 6, type 7. These are the major important type of grinding wheels I mentioned here. You can look into it. Next, we moving into characteristics. Characteristics of a grinding wheel. First and foremost thing of the grinding wheel is abrasive material used in that grinding wheel. It is nothing but the primarily the aggressive abrasive aggregate is selected primarily according to the hardness of a material being cut. Chemical compatibility is also a concern. I mentioned earlier that the job we need to perform it's a hardness and the work on the abrasive material on the grinding wheel abrasive material should be higher than the job we going to perform, then only the surface finish will be good and we expected. So it's chemical component also taken into consideration. If we take iron and here carbon means we need to compare the chemical compatibility between them and we need to perform that job. Grinding will consist of hard abrasive grains called abrasives, as we also mentioned in the previous slide. For example, carbon alloys with iron, silicate carbide is not suitable for use with the iron-based metals like steels. Here, the chemical compatibility and the is not matched. So this type of if performance it will result to poor finish. Next grinding wheels with the diamond and CBN or super rubber. As we mentioned, diamond is ultimate hardness and CBN grains. So it is also called a super abrasive grinding wheel particles. Next, we moving into grain size. Grain size means as I mentioned in that slide, there is a small structure, small structure like in the grinding wheel. So it is known as a grain size. It will be varying according to grinding wheel. There are totally three types of grain size materials like coarse, finest and ultra fine. For it is from 10 it is coarse to 600 to finest, determine the average physical size of the abrasive grains in the wheel. A large grain will cut freely. It means if you use coarsest and finest materials, it will be able to cut freely, allowing fast cutting. So it will also able to cut fast but poor finish. If you use coarsest and finest grain size grinding wheel means it will leads to poor surface means, but your work will be done in at a fast manner. But using ultra fine grain size or precision for finish work, as I mentioned earlier, I think it is ultra fine means it is like a dense like structure grinding wheel. It is a open structure wheel. It is the major difference between them. Generally, grain size of the grinding wheel are 10 to 24. See, this is coarse type 10 to 24, 30 to 60 means medium, 80 to 200 means fine, and 200 to 600 means very fine. These are all the parameters you need to consider while buying a grinding wheel. I explain detailedly in the further slides on what are the parameters should the grinding wheel be buyed on the shop or in the industries on the industry making machines. So next, grain spacing. As I mentioned here, it is nothing but the distance between the grains, spacing or structure. It is also named as the 1 to 17. 1 means densest and 17 means least dense, as like a dense structure and the open structure. It is also depend on the ratio of bond and abrasive to the airspace. Bond is nothing but the material we use to bond the abrasive grains to make a complete to make a complete grinding wheel. So we look into different types of bond in the next slide. The less dense will cut freely and harder and has a large effect on the surface finish. So I mentioned earlier, same thing is mentioned. It is also able to cut deeper or wider cut with less coolant, as a chip clearance on the wheel is greater. Another point of consideration is while the grinding operation is performed on a job, a grinding tool is rotating opposite to the job. A coolant is also providing on a grinding wheel. So on that consideration, in open structure, the coolant should be adder itself, and it should able to liberate the heat as much as he can. So Coolant is one of the important parameter while the grinding operation performing, because on a high hardness surfaces it will liberate a high amount of heat. So to satisfy that, high amount of high coolant should be made with the grinding process. Next, moving to wheel grade. Wheel grade, A means soft, Z means hard, determines how tightly the bond holds the abrasive. So A to H is a softer structure, I to P is a moderate and hard structure, and Q to Z is a hard structure. As is mentioned, how tightly the bond holds the abrasive. There is a gap. There is a gap. There is a relation between the bond and the abrasive grain particles. That means grits. These two attaching material, these two compatibility should be very high. Means it is hard. That means it will fall under Q to Z hard structure. These are why I'm mentioning A to B, H, I to P. These are all the technical terms used. Technical terms. These are specification terms used in the grinding wheel. With the help of this, we can find A to H. If we designated B means it is like a softer structure grinding wheel. Or if I to in between I and P means it is a moderate hard structure. In between Q to Z means it is a hard structure. So only these are all the names assigned to that. And grade affect almost all consideration of the grinding, such as it affects like wheel speed, cool and flow, maximum and minimum feed rates, and the grinding depth. These are all the affecting parameter of the grinding. Next, moving to these are the three major importance taken into consideration on the grinding wheel. First and foremost, in abrasive grains. Next, to bond. Next, to pores. So, in the structure slide, I said that these are the three will be mentioned in that, like abrasive grains, bond, and the porous. Grain, it is nothing but as a cutter, and mainly they remove the surface of the work pieces. Next, to bond, as I mentioned, the said bond is a ties grain together. There is a here one grain, here one means the two grain will need to adhere oneself, means it the um, joining material is acting as a bond which ties the grain together and holds them in position when loads are applied during grinding. As you mentioned the earlier, when the lateral loads are applied on the grinding wheels, the bond is the major factor to hold that, to bear that load capacity, and that offering resistance to that. So it is classified into vitrified, silicate, rubber, shell lock, and metal. Vitrified in the next mixture of clay and water with the abrasives, and silicate in the sense abrasive particles with silicate and soda or water glass. These are all the materials we used for bonding the grains, that means grits together. Rubber means mixing abrasives with pure rubber and the sulfur. Shellac means mixing abrasive with shellac, then molded by rolling and pressing. Shellac actually it is performed by two processes like rolling and the pressing manufacturing process. A metal, when the powdered metals or compounds containing a cubic boron nitride or a diamond are sintered into the wheel. As I said, in the diamond wheel, the metal only major thing, diamond will act as a grain particles, in small particles, and the bond will be made with them with the help of powdered metal or compounds. Next, pores. It provides a gap necessary to remove chips producing during the grinding. As I mentioned, when the grinding wheels performing an operation, there comes a chips. So to provide a necessary gap to remove the chips, it will be given by porous and hold and supply coolant to the grinding points. It will also hold and supply the coolant the grinding points to the various grids present in the grinding wheel, and release heat generated at the grinding point into the atmosphere. As I mentioned, when the grinding wheel is performing, its hardness is too high. That means a high liberation of heat is accounted. So to liberate that, pores is the one of the main thing which liberates the heat from the grinding wheel. Next, it is a nomenclature. So these are all the factors you need to consider while buying a grinding wheel or manufacturing a grinding wheel. So first, the prefix manufacturer symbol. It is nothing but the industry specified person will have some code, like 51 means he must have some code, or 51 means it is not my job. So you leave into that. We can see abrasive type C. C means in abrasive, natural or artificial. In artificial, C means silicon carbide. Oh, while you look into the name as C means, it is like silicon carbide. Silicon carbide abrasive type is used. Next, moving to grain size. Next, grain size in the sense, as I mentioned earlier, coarse, medium, fine, and very fine. 45 falls under medium, so it is medium size, medium grain size grinding wheel. Next, moving to grade in the sense soft, medium, and hard. So O falls under medium type, so it is a medium grade type grinding wheels. Next, moving to structure in the sense dense or open. So dense in the sense I mentioned earlier, it has grids. Grids having small space in between them. That means that has too high surface finish. So dense means 13 means it falls under the open structure type grinding wheel. Next, bond R means rubber type. They are vitrified silicate and rubber. They use a rubber like bond type to bond the grids of the grinding wheel. Next, manufacturer record. This private marking to identify the wheel. This is also not considered because it is too dependent on the making or the producing member of the grinding wheel. So these are all the things you need to consider while purchasing a grinding wheel or manufacturing a grinding wheel. Next, this is a grinding wheel. We can see the specification, what all the mentioned in the grinding wheel. The first and foremost, they will give a trademark in the sense brand. What is the brand is used in the grinding wheel? Next, test record. What are the tests performed in the grinding wheel? They will be mentioned in the code size. Next, the restrictions of issue. They will have some restrictions. You should not use in this condition. You should not use more what to say use in that machine grinding machine. So there are some constraints which will not to use in that for this grinding wheel. Next, expiry date will be mentioned on the right side. Next, speed stripe in means rpm. While there will be some rpm, it is like if we have blue stripe means blue color stripe means it is like you should perform very slow type of rpm. If you have yellow means it is a medium type of rpm. If you have red means you can perform up to 80 meter per second, I think so. You can perform, and that much rpm you can rotate that grinding wheel on the job you perform. So this stripe it will be in three major colors. Next, dimensions in it will be what is the dimension like this, length, breadth, and width. Next, specification mark. So as I mentioned that specification mark also used. So see here, so this are the specification 51 Siemens here as WAC. These are the specific marks mentioned in the grinding wheel. Next, the code number also mentioned. Next, maximum operating speed. Here you can see 1600 RPM is the maximum RPM and 50 meter per second. So it will, I think it is fall under yellow stripe, speed stripe grinding wheel. And ISO type, Indian standard type, what is the type is used. And also mounting instructions also mentioned in that grinding wheel. So these are all the information I gathered using the grinding wheels. Thank you for giving me the time to explain this presentation. Thank you.